Okay, so another app that I like to use is really good for the mind. It's called Brilliant, and in it actually gives you some daily exercises to sort of do and work through. And well, it really helps sharpen the mind. So, for example, let's have a look. We've got here in that probability section, we can click on, I believe. So I just clicked on there. It's just, oh no, here we go. So today's problem. So we've got the nurse at the hospital is a little bit absent-minded, and today he's forgotten which 4 hats are supposed to go with which baby. Whoops! If he decides to fix this mistake by giving each of the 4 babies a hat at random, a very important point there, random, what is the probability that all of the babies get the correct hats? Okay, so this one's pretty straightforward, really. What we have is a situation where there's only one set combination of the ways in which the hats can be placed correctly for each of the 4 children, and then that's going to have to be decided against how many different combinations, how many different arrangements that these babies can have their hats put on. And well, I know a quick way of working out. It's called 4 factorial, but I'll explain the premise behind that. So let's say we have red, blue, yellow, green, and let's say we wanted to put the one way we could do this methodically is to say, well, let's say the first one stays red, we have blue, yellow, green, and then we could switch out the first 2. So we could be like red, green, yellow, blue, and then we could do another one where it would be like red, blue, yellow, green. So once you have the first one fixed, you can switch out the other 3 in 4 combinations, and then you can switch out the first one, the red, so we can swap that, and we can start with yellow and then swap them accordingly. And so we get this pattern here where we've got the firstly 4 ways in which to do that. Then because we've utilised the first colour, we're then left with 3 remaining ways to do that, 3 lots of the 4. And then with the second one, we have 2 lots of that, and then lastly, we have 1 lot of it. So essentially, we get 4 times 3 times 2 times 1. But there's only one combination out of that. So it's going to be 1 over 4 times 3 times 2 times 1, which is something like 4, 3, that's 12, 24, 1 over 24, which is about, God, 0.041. And that would be, as a percentage, approximately 4%. So we can assume that that should be the answer. Check answer. There we go. That's correct. And we can actually go here, discuss explanations. This is what's good about it, actually, is that you can discuss the explanations. So, and also here, you can vote up the explanation. So the person that actually submits the best explanation. I mean, I've submitted explanations myself, and I've had them voted to the top. If you articulate an explanation really well, people will vote it up. And so we have Philip Grieve here saying, similar to the example, you must simply multiply the chances of each choice. At first, you have a quarter of a chance of choosing correctly. Then in your next choice, a third of a chance. With only 2 hats at this point, you have only 2 choices to make, and therefore half a chance. They've all been multiplied together in fraction form. So that's one example. Okay, so I've just come on to this problem here. It says daily problem, science and engineering. It's about noise cancelling headphones, which is something I actually have, so I might have an advantage here. It says, can you engineer these noise cancelling headphones? Now, here we have here. Regular headphones can block out some noise simply by providing a physical block, as you would have experienced before you put headphones over, and it cushions and reduces ambient sound from the environment. They reduce the amount of sound energy that reaches your ears via passive noise control. Like regular headphones, noise-cancelling headphones block noise passively, but they also have a built-in microphone to detect background noise. Once they've detected noise, the headphones produce sound waves to cancel it out. Yes, yes. How exactly do sound waves cancel? Sorry, this is a question. Sound waves travel through air as a pressure wave, compressing and expanding the air. This disturbance of particles is the sound wave. To cancel the sound wave, these disturbances would need to stop. In other words, the particles would need to be completely undisturbed. Here we have a little dynamic graphic showing that. You've got a sinusoidal wave. When noise-cancelling headphones produce sound waves to cancel out ambient noise, these waves expand air where the ambient noise compresses. To compress air where the ambient noise would expand it. The result, the air is neither compressed nor expanded. The sound waves from the ambient noise disappear because the waves are exactly cancelled out by the waves produced by headphones. This is called active noise control, and it is what makes noise cancelling headphones much more effective than standard headphones at reducing the noise you perceive. Today's problem: extremely loud noises can damage your hearing. That's why people who work around loud noises, like airplane engineers and mechanics, often wear large headsets with a thick layer of foam. This blocks out much of the ambient sound through passive noise control. Suppose that you want to develop a pair of noise cancelling headphones to protect an airplane engineer from hearing damage. So it says here the question: how would you alter the design of your standard noise cancelling headphones so they could actively cancel out extremely loud ambient noises? So that one should be pretty straightforward. Essentially, you need to produce sound waves that are out of phase with the environmental noise, the ambient noise, and you have to bear in mind that when you have louder noises, you have a higher amplitude. And so you need to produce waves that are out of phase to these high amplitude sound waves by increasing the amplitude of out of phase waves that your headphones are producing in the interiors to cancel out those waves. To do that, you're going to have to put more powerful speakers inside the headphones. So one option is to place holes where if you put holes in it, you'll be able to hear the noise even more. So that's stupid. Equip the headphones with more. Well, we wouldn't need any more sensitive microphones because the noise is really loud. So let's try the middle option. And here we go. We're correct.